try to define this problem. This problem is a little bit more complicated than the first one. Here you can see there is a drum. Okay. For this drum, the mass is not uniformly distributed, so a radius of gyration is given. This is the radius of gyration about an axis going through point O. So that's KO. Okay. And there's a code, okay, wrapping around this drum. And this code connects to a block. Okay, this block, its mass is 20 kilo. So initially, we hold this block, so the whole system is balanced. Okay. So if we release this block, what will happen? You will see this block will be going down, and this should be a rectilinear translation, okay? Because the moving path of this block will be a straight line. But how about this drum? Obviously, you can see for this drum, it should be undergoing rotation about its fixed axis 0.0. The target here is to determine the drum's angular acceleration. So how to do? And here it tells you the code of the mass of this code can be neglected. So that means what? That means for this whole part, including the code and the drum, the mass center of this drum will not be affected by this code. Okay, so how to solve this problem? We have defined this problem. We have defined the two motions of the two rigid bodies. And for solving this problem, and you can see in this one here, we have two rigid bodies instead of one. One is rotation about a fixed axis, and another one is rectilinear translation. So for solving this problem, we actually have two methods. We can consider these two rigid bodies separately, okay? One is the drum, one is the block. If we consider these two rigid bodies separately, then we will need two diagrams. One for the drum and one for the block. Okay, so this one is FBD for the drum and the kinetic diagram for the drum. And also we should have one FBD for the drum and one diagram for the kinetic diagram for the drum, for the block, sorry. Okay, now, for the drum, at this point, the mass center point, also the rotation center, we have WD, D for the drum. And at this rotation center O, we have reaction force OY. And also we may have OX. Okay, now, because in this one here, we are dealing with two rigid bodies, and one is rectilinear translation, another one is rotation. So it should be convenient to use x, y coordinate system. So in this one here, you can see my defined conventional x, y coordinate system. Okay, now in this kinetic diagram, I assume alpha is counterclockwise positive. For O, because O is the fixed axis of 0 point. So for this drum, no acceleration at this point O. Now, for this block, one more external forces is here, A. Okay, and at this point in this code, there should be a tension force T. Okay. Now, for the block. For the block, obviously, we have WB, the weight force on this block. And also we have T prime from the code. And here you probably can see T prime, both in the code. And these two should be equal to each other. The magnitude should be same, but the direction of T and T prime opposite. Okay. In this kinetic diagram for the block, because this is a rectilinear translation, so we have M, B, A, B, Y. And A, B, X definitely should be 0 because the motion is rectilinear and downward. Okay. So for this diagram, do you have any questions? Any questions? Okay, so that's the diagram for the first solution if we consider these two rigid bodies separately. There is another solution. We also can consider these two rigid bodies in a system, okay? If we consider these two rigid bodies in a system, what will be our free body diagram and kinetic diagram? We will only need one free body diagram and one kinetic diagram. Okay. So if we consider these two in a system, what will be the diagram and help them? Okay, now, again, for this drum, we have WD, we have OX at this axis, and we have OY. And also in this one here, we have WB. Now, how about the tension force from the code to this drum and the tension force to the block? Should I indicate this tension force here? Should I? The answer is no. Obviously, now in this one here, you have T and you have T prime. But we are considering this drum and this block in a system. And in this free body diagram, we only need to indicate all external forces. If we consider these two in a system, including this code, then T and T prime, these two will become internal forces. Internal forces always appear and they can cancel out each other. So it's not necessary to indicate T and T prime. Okay? Again, we only indicate external forces in the free body diagram. Okay? Now, in the kinetic diagram, at this point, mass standpoint of the block, we have M, B, A, B, Y. Okay? And here, again, we have this. If you consider this drum and this block in a system, and you will find actually for alpha and ABY, for these two, they are related to each other. Alpha and ABY, they are not independent. They depend on each other. So if ABY downward, then you know this alpha should be counterclockwise. Okay? So that's the diagram for the second solution by considering these two rigid bodies in a system. For this one, do you have any questions? Okay, no question. Let's have a look at the solution. Okay, here. So firstly, to define this problem for the drum, for the block, and also notice the code has negligible mass. Okay. Negligible mass. For the solution, we have two methods. One is to consider the drum and the block separately, and one to consider them in a system. Now, for the first solution, okay, for the first solution, we consider these two rigid bodies separately. We have to indicate T and T prime because they are external forces if we consider these two rigid bodies separately. And we know MB, we know MD, we know a radius of gyration of this drum about 0.0. And again, at this instant, when we release the block, at this moment, at this instant, omega, or the velocity of the block, still 0. Okay, we don't know OX, OY, and we assume they are positive. We don't know alpha, we assume it's positive counterclockwise. For T and T prime, because they are a pair of forces, so they have magnitude, same magnitude but opposite direction. So we can't assume both of them positive. Okay? We just use their real direction in our following calculation. Okay, only 3 equations we can use because we are considering these 2 rigid bodies separately. So for each body, we have to apply these 3 equations. Now, firstly, for the drum. Okay, for the drum along x direction, you will see you only have OX in the free body diagram and AOX because it's the x is a through point. So at this point, acceleration must be 0. Okay, so OX should be 0. So this should be easy. Now for y direction, okay, y direction. Along y direction, we have OY, we have T, we have WD. Look at this diagram. T, unknown, downward, negative. So I have a negative sign before T. WD, it's downward. So for WD, I also have a negative sign in this calculation when I substitute the number in this equation. Okay, so OY, T, WD, OY, acceleration AOY, this component is also 0. So we have another equation about OT and T. Now, for the third equation, and this is the rotational component. The calculation can be about the rotation center and also the mass center point O. Okay, now T downward, T about O, the moment is counterclockwise. Counterclockwise, according to this coordinate system, it should be positive. So that's why for this item here, you can see it's positive. Okay? Now, on the right side, IO can be easily calculated, and alpha, we don't know. So, in this third equation, we have T and alpha. We have 2 unknown parameters. So at this moment, we still cannot solve this problem because we have already got 2 useful equations, 2 and 3, but we have O, Y, T, and alpha, 3 unknowns, and we need another 1 equation, and this will be from the block. Okay, so for this block, we should have 3 equations for this block. But because this block is undergoing rectilinear translation, okay, downward. So this means in this case here for this block, only 1 equation along the y direction, translating the component along y direction. Only this one is useful. Now look at this diagram. For external forces, we have T prime and W. T prime is positive, and W, B is negative. Okay. For AB, you can see AB, this direction should be related to the direction of alpha. Okay. So when you express ABY, the magnitude is alpha times R, and the direction of AB must be downward. Downward is negative, so you need to give a negative sign. Okay, now this is your fourth equation. In this fourth equation, we have t prime, we have alpha. Now, we have already got 3 equations, and we have got 4 unknowns. But t and t prime, they must have same magnitude. So finally, that means we have equation 2, equation 3, and equation 4. 3 equations and also 3 unknown parameters. So we can solve this. And finally, we can get alpha should be 11.3. And this is positive. And that means the assumed and also indicated counterclockwise direction for alpha is correct. Okay, so that's the first solution by considering the drum and the block in a system. Any questions for this first solution? Any question? Okay, now let's have a look at our second solution for this same problem. And this time, we consider this drum and the block in a system. Okay. We have already drawn the diagram, and we can collect all the parameters here. We have O, X, O, Y, alpha. And this time, we don't have T and T prime because they are external forces. We don't need to consider. And we assume OX, OY, alpha are positive. Okay, now we will apply these 3 equations to this system. Okay. And G, this G, in this expression here, G means the mass center point of this system consisting the drum and the block. Okay. But when we do our calculation, because we actually don't know the location of the G for this block, for this system consisting the drum and the block. So actually, in our following calculation for AGX, we will use the acceleration at the mass center point of the drum and also the mass center point of the block for our calculation. Okay. Then just simply add up. For the rotation component, for this problem, we will use O for our calculation. Can we use G, the mass center point of this system, for our calculation? Theoretically, you can, but the issue is you don't know the location of the G, the mass center point of this system. And also it's unnecessary to know that. So using O for our calculation will be convenient. Okay, now along X direction, if you look at this diagram, you have only OX. So again, you can easily get OX should be 0. Along Y direction, you have WD, OY, and WB. Okay, this is 3. So we will put this 3 all together, and here OY is positive WB, WD, both downward should be negative, okay, negative. And on the right side, AOY and AOY should be 0, but ABY, again, ABY can be expressed using alpha and RD. Again, before ABY, you should have a negative sign because you already know in the diagram it's downward negative. So we can work out our second equation. And then for the rotational component, look at this diagram. About point O, only WB has a non-zero moment, and it's counterclockwise positive, okay? Only WB needs to be considered, okay? And it should be positive. On the right side, we have IO alpha, and also we have the kinetic moment generated by ABY about O. Again, this is counterclockwise positive. This item, okay, is positive. So we have equation 2 and equation 3, only two unknown. One is OY and another one is alpha. So we can solve. Again, you can see the final answer 11.3. This is as same as what we have got in our first solution. Okay.